have two functions. We have f of x and we have g of x. The top graph, the positive parabola, is labeled f of x. The negative parabola, the one that's facing upside down, is g of x. What we have to do is basically use these coordinates to then graph f of x plus g of x, as well as f of x minus g of x. Okay, so I'm just going to read this out. The graphs of two quadratic functions, y equals f of x and y equals g of x, are shown on the grid. The points marked with dots have integer coordinates. So basically, you're not going to have decimals. Okay, what we're going to do, essentially to figure out these operations, is look at the y coordinates, given the exact same x coordinates. And in this case, we're going to add them together. In this case, we would subtract the y coordinates. So x will always be the same for the function. It never changes. I'm just going to walk through the first one and then see how you guys do. Okay, so let's just find on this parabola the same x value as this parabola. So maybe we'll start at this one here. So where x equals -3. Okay, there's 2 points on each parabola that goes through x equals -3. We'll mark them here in red. Okay, on y equals f of x, the y coordinate is, if we count, it looks like the scale's going up by 2, so we have 24 here. Y equals 24. And here we have 1. So remember in the last example I said that f of x, g of x, it's basically like we're calling that a y, the y coordinate. And pretty much it's telling us y is equal to that too. So what we need to do is add these y coordinates, given a specific x coordinate. I'll just write a little side note. Add the y coordinates of each function f of x plus g of x using the same x coordinate. And what's going to be helpful is I'm going to make a little table on the side here, and I'd recommend using whatever space you have in your workbook, try and make the same. Okay, so we're going to have an x coordinate, and then we're going to use f of x plus g of x. So in this case, the x coordinate I chose to start with was -3. When x was -3 on f of x, what was the y coordinate? 24. And the y coordinate on g of x? 1. So we're going to add those, and we get 25. Okay, now let's line up when x equals -2. Okay, on f of x, what's the y coordinate? We count up. So 2, 4, or 10, 12. Okay, and then on g of x, what's the y coordinate? 4. So if we put those together, on f of x we had 12, on g of x we had 4, so our new y coordinate is 16. I'm going to get you guys to help me. Can you calculate f of x plus g of x when x is -1? So if it helps, draw a line through the point. Remember, the scale is going up by 2, so if it's in the middle, then it's just 1 up. Sadie, maybe you can help? You're Sadie, right? Is there a Sadie in here? No. What's your name?
Jane.
No, Josie, right?
Me?
Yeah, sorry. Sorry about that.
No, that's it.
Josie, what'd you get?
Like 4 plus 5.
Good. 4 plus 5, so you got 9. Awesome. When you're creating a table of values, pretty much what you want to do for the x coordinates is start at -3 and go up by 1s all the way to +3. So let's just calculate when x is 0, what is f of 0 plus g of 0, basically. Okay, on f of x, looks like we're at 0, and on g of x, looks like we're at 4. Okay, so this one will be 4. Who is totally lost? So everyone's feeling good? Nice. Yeah.
Like, why did you start at -3? Because that's the farthest over that one goes, or something?
The reason why I started at -3 is because there were 2 points that lined up where x existed on both graphs. Now if I went higher, I could probably see where that point is, but right now this is the greatest one that's showing, so I just started on -3. And typically, if you have -3 to 3, you're going to have enough points to see what the characteristics of the graph are. If you just did 2 ordered pairs, then you're not going to get to know much. Okay? So when x is equal to 1, did anyone calculate that? 1? Okay. What about at 2? 0. And then at 3? 1. Can you guys guess if I calculated at x equals 4 what it's going to be? What? Yeah, 4. Okay. Basically what we have is a parabola. 25, 16, 9, 4, 1, 0, 1, 4. Okay? It's symmetrical. What would be the next value? 9 then? 10? Very good. Okay, so we're creating a parabola here. So what I want you to do what I want you to do now is just take these ordered pairs that we've solved for, and you're going to plot them. Okay, so -3, 25. We're going to plot that. And then -2, 16. -1 and 9. Don't forget, scale is going up by 2s. 0, 4. 1, 1. 2, 0. And then we're symmetrical again. So if I asked you guys to do this using f of x minus g of x, do you think you would be okay? Instead of adding the 2 points, you would subtract them? Do you guys want to go through that, or do you think you're okay? Tell you what, if anyone wants to go through it a little bit more, we can take it up after the lesson. Okay, but I think just going through f of x plus g of x, you get a good idea. If you were to graph these, you would see that they're exactly the same. Hold on. That's okay. We'll just leave it at that. How about we just state the domain now of what we've graphed? Okay, so going on to D, we're going to state the domain. How about Jackson? Am I getting names wrong, or your name is Jackson, right? Yeah. Okay, good. Okay, what's the domain of the parabola?
X is an element of all the elements.
Perfect. And the range? What's the lowest coordinate you can see in the, either on the graph? Good, so,
Y is greater than 0.
perfect. Is it gonna be equal to 0?
Yeah.
Okay, so our domain is x is an element of real numbers, and our range, y is greater than or equal to 0, and of those numbers, they're real. So basically I skipped B and C because I think you guys know how to put in a function into your calculator, and you would just see that they are exactly the same. So we just skipped over that. This last part, E, it's a little bit, it's going to make you think a little bit. In this example, the sum and difference of two quadratic functions are quadratic functions. So what we just figured out is when we added f of x to g of x, the result was, again, a quadratic function. Okay, do you guys think there's ever a case where you would add two functions and it wouldn't be a quadratic function? Is there any possible way that could happen? It's a tough question, so I'll just go through an example here. Let's say we had f of x equals x squared plus 3x plus 2, and g of x equals x squared plus 2x plus 4. Okay? If I were to subtract f of x minus g of x, what's going to happen to the x squares? Cancel out. Okay? Then 3x minus 2x is just x, and 2 minus 4 is negative 2. So now instead of a quadratic function, what do I have? A linear. Okay, so there is a way of having a solution that isn't necessarily degree 2. It could be degree 1. Or in the case that the x is cancelled out, you could have degree 0, which is just a constant. Okay, so there are some cases where you don't always get quadratic functions or parabolas. Sound good? So the last, we have a few more, sorry. Okay, so now we're just going to take a look at functions rather than graphing them, and we are going to evaluate. Okay, so here f of x is given as x cubed minus 2x squared plus 6, and g of x is given as x cubed minus 2x plus 6. You're going to take the two functions, and in part 1 here, you're adding them. In part 2, you're subtracting them. So if you're feeling confident, you can go ahead and do that. And if not, I'm just going to keep explaining on the board here. Okay, so f of x is given as x cubed minus 2x squared plus 6. I'm going to sub that in instead of f of x. And I'm going to add that with g of x, given as x cubed minus 2x plus 6. Combining like terms, I get 2x cubed minus 4x squared plus 12. Yeah.
So
Did I
there's
miss-
only one 2x squared, and then in the second term.
Oh,
just
sorry.
x.
I was thinking x squared. Thank you. Okay, so sorry, minus 2x squared, minus another 2x, and then plus 12. Good, you guys aren't sleeping after all? Okay, part 2, we have to subtract the two functions. So we have x cubed minus 2x squared plus 6. And we're subtracting x cubed minus 2x plus 6. So the x cubes cancel out. And we get negative 2x squared plus 2x. And the 6's also cancel out. So for part B, it's just kind of testing your knowledge on what operations we've been doing. F of x plus g of x is a what of two functions? What math operation have we been using? In other words, what's another word for adding? The sum. Okay, and in this example specifically, f plus g of x is 2x cubed minus 2x squared minus 2x plus 12, what we just solved for on the left. For part 2, f of x minus g of x is a difference of two functions. We're subtracting them. And we can write that as, in brackets, f minus g of x, and that equals the function that we found on the right. Negative 2x squared plus 2x. So now that we found the expressions, we're going to evaluate. Instead of using x, we're going to use negative 2. Okay, so for f plus g of negative 2, instead of the x, we now have a negative 2. So what was f plus g of x? It was this right here. What's going to replace that x? Negative 2. Here, negative 2, negative 2, negative 2. We're just going to sub in a negative 2. So as a reminder, f plus g of x was equal to 2x cubed minus 2x squared minus 2x plus 12. We are going to replace the x with a negative 2. So I'm just going to erase the x here and put negative 2, negative 2. Don't forget to use brackets. Negative 2, negative 2. So when you evaluate that, what do you guys get? What'd you get, Stan? Negative 8. Okay, everyone agree? Good stuff. Okay, how are we feeling with these? Should we try the next one or can we move on? Okay, we're gonna finish on a word problem.
Junior class change.
And then you guys will have some time to practice. Alright, we need a new voice. Who's going to read the question? Ben, thank you. Go ahead, Ben.
A multimedia production company produces DVDs which cost $3 per unit. The fixed costs include graphics are 10,000 irrespective of the number of DVDs produced. Each DVD retails for $15. If X is the number of units produced, answer the following in terms of X. Keep going.
Sure. You're doing great.
Write the total cost, C, of X as a function of the number of units produced.
Okay, awesome. So basically there's two parts where we're going to have to create function equations. So one is for the cost, one is for the revenue. So let's go back to this word problem and dissect what is going to give us the cost equation. Okay, reading it again, a multimedia production company produces DVDs which cost $3 per unit. Think that's important? Yep, so let's underline that. Okay, the fixed costs, including the graphics, are $10,000 despite whatever number they create of DVDs. Okay, so fixed cost, that's an important word as well, is $10,000. Okay, do you think it matters that the DVDs retail for $15 when we're talking about cost? No. Okay, so the cost, C of X, will be equal to, any guesses? Is it gonna be a linear equation, a quadratic equation? Linear. Okay, it's $3 per unit, so that's 3x. And then it says our fixed cost, so that's like a constant, is going to be 10,000. Okay, no matter how many DVDs you sell, it's always going to be $10,000 up front. Now let's take a look at our revenue, R of X. Okay, how are we going to figure out that? It's $15, right? Times the number of units that you sell. DVDs. So if we want to figure out the profit, what's going to be the formula using our cost and revenue? Pardon? So you go your cost minus revenue? Okay, very good. Okay, revenue, subtract your cost. So if we sub in the formulas that we had from above, that would be 15x subtract 3x plus 10,000. So we end up with 12x minus 10,000. That's our profit. So the last part is calculating what is the profit if we sell 20,000 DVDs. So what's your X going to be? 20,000? So what do you guys get there? Go ahead, you're right. 230,000. Pardon me?